Hey guys, Mr. Stewart here, and I wanted to let you know that I am not in class today because my cough has proven to be debilitating and I'm having a lot of pain, especially by 4th block. So I'm not going to be in class today and I'm going to take a day to kind of recover and try to feel a little bit better. Um, so as we don't have a teacher today, you're going to be doing some review and starting your atom model project. So first thing is to watch this video, of course, and I'm going to show you guys kind of what the project is all about and how things are going to work. Uh, and so in Google Classroom, the assignment has been posted. The first assignment is to watch this video. Watch the video that I'm posting here. You're going to use the document, the Atomic Model Project, to reference. It's got everything. We're going to go through it together. The assignment number 18, the model plan, is going to be what you're going to turn in on this assignment itself. And then I've given you an assigned element. So everybody's going to have a different element that they're going to be doing their project on and building a model of. So let's look first at the Atomic Model Project. So the assignment is to do an element. You're going to build a 3D representation of one atom of that element. So no flat models. You're not going to be putting this on a piece of paper and just drawing a picture. You must use materials other than paper. So styrofoam balls, wood, balloons, food, pipe cleaners, kind of anything creative that you want to use, you can create. Separate colors should be used for each part of the atom. And I do want you to include a key. I get a lot of students who don't actually include a key for this document. There is no key. You're automatically going to get a worse grade. If I don't know what your neutrons are, I don't know what your protons are, I don't know what your electrons are, I can't grade it appropriately. The second part of this, well, the third part of this project, is a 300-word minimum typed essay. Okay? So now 300 words is not that much, so you guys should be aware it's not a lot, and I've really set it up for you quite well. So the first part of the project is our atomic model plan. It's attached down at the bottom, and this is going to be the outline for your essay. Your essay is going to be based on this atomic model plan. The way I've set it up is write the paper. You really just have to put the stuff in the plan in paragraph format. I do want you to make sure you're including bibliographic information. If you don't include bibliographic information, you're going to result in fewer points. I do not want you to cut and paste from other websites. You have to use your own words. It can be paraphrased from somebody's website, but it must be your own words. I don't want you to just cut and paste. Now for your model, it should be scientifically accurate. It should have the proper number of protons, neutrons, and electrons, and it should be properly labeled. Once again, there's that label word. I want to see that key. Your model is going to be graded on creativity, imagination, and scientific accuracy, and it'll be 2 project grades and 1 homework grade. The project grade is 100 points. The essay is. The model is 100 points, and the homework assignment, the plan, is also 100 points. This homework is assignment 18. The project themselves are 20 and 21. The model and the essay. Due dates. This Thursday, so you got today and tomorrow to work on this this project plan. It should not be hard. You should finish most of it in class today. And then the model and the essay, you'll have the weekend and the rest of this week to work on. It'll be due next Tuesday. Don't wait till the last minute to do this. You've got the whole weekend to work on it. You've got all this week to do it. Use your imagination and creativity. Please don't go out and buy anything. You don't have to go out and buy things. You can use supplies that are around your house. You've got recyclables, you've got bottle caps, you've got all sorts of things. You could use toys, anything you want to use besides just flat paper and markers. You can use. Now, if you really have some issues getting supplies, you can let me know, and I will try to help you out. So let me show you guys what your assignments are. They're attached to the spreadsheet that I'd given you, and that spreadsheet is in Google Classroom. I've got it open already. And so basically what I did was take all of your names, I randomized them, and then I went through the list and I just put them down. And so you're going to be building atoms 1 through 32. I've skipped a few in there. I skipped 20 to 26. I went to a few that were kind of important. And those transition metals that we haven't really talked about. So everything that's in here is either an important element to what we've done, or it's also in the same families as the ones we've done. Gallium and germanium are both in the group near metalloids and the nonmetals. So you guys who have the bigger atoms, you might want to make sure that you're working on those because they do have a few more particles. And this was random, so you guys should be working on those, but make sure you've got them written down in your assignment project plan. All right, so that's where that is. Now, here are the rubrics. I've given you a rubric for each of these. All right, the first 4 here are for your model. And so to get a 100, you want to have everything in this top row here. All right, to get a 100 on the model, it needs to have the correct number of particles. It needs to be well constructed and creative and of reasonable size. It needs to have a color key that's easy to read and all parts are present and correct. And it has to be on time. That's next Tuesday. The essay should be fairly easy. All right, a 100, you effectively discussed the element in detail and included all the required information. To get a 90, it's not as detailed. Okay, that's the distinction between a 100 and a 90. The distinction between an 80 is that you did not include all the required information. And a 50 is if you don't meet the word requirement or you plagiarized it. Now that's what I'm going to do. I'm going to look for plagiarism, and if you haven't done it, I'm going to dock you points. So please don't just copy word for word from a website. That's really easy for me to figure out. So that is your paper. Now the plan is pretty straightforward. If you complete it, you get a 100. You got answers in every single one of those spots. You filled it out. For 10 points off, you didn't find information about 1 to 4 topics. For 20 points off, you didn't find information for 5 to 8 topics. And if you did at most half, or you did not include your sources, all right, this is the big one. You did not include your sources. I'm going to talk to you all about that in just a moment, but I want you to include sources. You have to tell me where you got your information from. You'll be turning in your paper online. You will be turning in your project, the model in class. But you'll also be turning in the plan, this plan. All right, so here is our plan, and I'm going to just kind of give you a little rundown of how this plan works. This will be yours. It will say Atomic Model Project up in the top, and it'll have a dash and then your name. And you're going to put in your element name. Now, my element name that I'm going to just pick for fun is thorium. I spelled it wrong. And it is in the actinide series. That is the group that it's in. It's in period 7. That's the 7th row, and it's atomic number 90, which means it has 90 protons, it has 90 electrons, and I'm going to have to look up the mass. I have to look at the mass to find the neutrons. Now, I just had a little mishap and didn't realize what happened to the research tool in Google. Well, they've changed the research tool. And so that's where I was going to go to find this, and then it disappeared on. They've changed that to be the Explore tool. So the way we do this is we look at tools and we go to the Explore category. And the Explorer here takes us and it opens up this little window over here. So this little window has our Explore, and I want to search for thorium. And thorium is right there, and it's going to give me some information. All right, and so I've got this stuff from Wikipedia, but I'm going to go ahead and skip the Wikipedia, and I'm going to go to a website like Energy from Thorium. And I'm going to go over here, and I'm going to see what they say. And I'm just going to open it. It's going to open in a new tab. And I'm going to see what the mass of thorium is. It's giving me some information. That's pretty cool. The film, remix, history, principles. So it takes some reading to figure out some of this information. And so as I'm looking through this webpage, I'm trying to figure out what these are. And here's some information about the atomic theory. There's a picture of an atom. We've seen that sort of picture before. And so what I'm looking for is information about thorium. And so let's look at this other page. Yeah. All right, molten salt, interesting. There's some stuff down here. Fuel cycle, uranium-235. I'm not seeing any information about thorium. This would be something to read about a little bit as we go on a little further down. But really, I want some information just about the atom itself, the neutrons in thorium. So another resource that I might actually use would be, let me look, thorium P table. Let's see if that shows up anything on the periodic table. Element number 90. There we go, rsc.org. Now we know that orgs are pretty good, reliable websites. So let's look at this one. Element 90 thorium is the URL, so that looks pretty good. It's going to pop up and it's going to show us when it was discovered. Hey, this is a pretty good website. We might need to keep this one up. All right, we've got atomic number. We've got relative atomic mass. There we go. Relative atomic mass is 232. All right, so 232 is our mass. So I'm going to go ahead and I'm going to type in right over here neutrons 232 minus 90 equals, just for my research, because that's not the number of neutrons, but that's how we find it. And I'm even going to go and open up and just 232 minus 90 equals, and it even tells me right up there 142. So I've got 142 neutrons in thorium. Now, stable isotopes is another question. Now, this is information that I could have gotten from from my periodic table, which doesn't really need to be cited. But the stable isotopes does really need to be cited. And so what I'm going to do is I'm going to go back to this website and see what that said about isotopes. It says key isotopes here are thorium-230 and 232. All right, so I'm going to put those in here. And one of the things that we can do is I can say thorium 230, and that needs a dash in between, and $232. No, these are key isotopes, not necessarily stable isotopes, because thorium is pretty radioactive. But these are my two references there, and I got these from this RSC page. And so what I want to do is I want to cite this as a footnote. And I can cite it. I can also select my citation format. And in fact, you guys should be using MLA. So there's MLA. And so that's the format we should be using. And let's go ahead and cite this web page as a footnote. And it gives me a little number up there. And then down here at the bottom, it actually plugs in the website that I've just used. And so you can see that down there. You'll need to find the year of discovery. That could also be from the same website. It said when it was discovered. Where was that year? There it is, discovery date 1829. So I can go ahead and put that in there. 1829. The name of the discoverer was in there as well. Those are all really good. Now, this is the name. I'm going to go ahead and cut and paste that because that I don't want to necessarily retype. And named after Thor, the Scandinavian god of war. That could be something interesting. And we want to know where it was discovered. Does it say where it was discovered? Let's put the history. Royal Karolinska Institute, Stockholm. It was discovered in Stockholm. Discovered near Brevig, Scandinavia. Brevig, Sweden. So that would be where it was found. Alright, so we can put that in here. Brevig, Sweden. Should be a G. Alright, so that's where it was discovered. Now, I probably should cite this. And so what I want to do is I want to go ahead and grab this, and I'll even stick this on and cite that same page. Now, do realize that we're going to want to have at least 3 citations. And I'm getting this information from one website that I can get some other information from another. So we can look for the reactivity. That's what does it react with. Some common compounds that our elements form. If you can't find any common compounds, like gold doesn't have any common compounds, or zinc doesn't necessarily have a lot of common compounds. Copper does have several common ones. You can say they don't have any common ones, but most of your elements should have a common one. The electron arrangement, I want to look for the valence electrons. How many electrons are these elements going to bond with? That's what I'm looking for. Their uses in everyday life. Where do you find your element every day? I find thorium in power plants. That's where it's used. In industry, it can be used in batteries and in motors and things like that. You can find where that is. Interesting stories and interesting information we can look for. I think in your document I've actually given you spaces for 2 of each of these. So you should have 2 of each of these in there. And then there's down here at least 3 resources. I've got my 3 or 4 citations here of the same resource. Alright, so I want to see 3 different sources in here. And you don't have to cut and paste into the bottom if you use the research tool to put them down here as a footnote. So I hope that explains it. You guys should be getting to work on this. Hopefully while you're listening to me talk, you've already started working. And if you have any questions, send me an email and I will try to get back to you as quickly as I can. Thanks so much, guys.